Alrighty, so this is for the year-end review assignment, and this is going to be focused on quadratics, the module that we just spent a bunch of time talking about through our knowledge of foiling, factoring by finding GCFs and expanding using the X table, and what we discussed today on Thursday, May 21st, the quadratic formula. So here's what the goal is. You need to do a couple things for me. You need to write a short paragraph that describes what quadratics are, and then you need to provide an example of a quadratic in real life. And that can be somewhere where you see the motion of a quadratic in a building, maybe where you see a quadratic in the motion of an object. And the really big hint on this one is basically anything that goes up must come back down. Gravity, that always makes some sort of quadratic type motion. Anyways, next, and this is probably the biggest one that you're going to be focusing most of your time on, you need to solve for quadratic equations. Four. Here's the breakdown, y'all. One of the equations can be solved, what we talked about today, using the quadratic formula, keeping in mind that the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all of which is in the numerator, aka over the denominator of 2a. And remember that from our conversation today, the a, the b, and the c, these variables, b, b, a, c, a, come directly from our standard form, ax squared plus bx plus c. But when we're solving for quadratics, we're always looking for where that equation is equal to 0. Therefore, our a, our b, and our c come directly in that standard descending quadratic form. If you have no idea what I'm talking about, that means you probably missed our session today, so go back on the YouTube channel and check it out. It is for lesson 25. It should be the most recent upload. All right, so you have to create 4 equations. Remember, you are creating these. You're solving these. You're not finding these in the book. You're making them. So one of them you make up and you solve with this formula. The other 3 equations can be solved using other tactics, primarily factoring. That's the big one. So at least 2 of them need to be solved by factoring. That's that X table talked about in lessons 14 and 15. And all your work must be shown. That is not an option. It has to be done. I don't care if you feel really comfortable factoring in your head, you must show your work. And no homework problems are allowed. No copying from a friend's assignment is allowed. These are your own original problems, which, by the way, is why I'm making this short little video. And I'll talk about that in just one second. Last but not least, how you do this is up to you. You can make a PowerPoint. You can make your own website. If you do, I recommend Google Sites. That's how I made my website. You can do a little mini write-up paper, or you can make and record your own short video where you describe all the work that you did, you narrate it, but remember your work must be visible. You'll have to show your work at some point too, to the point where I can see it and grade it. Whichever style you choose, you have to do all the above, where you write a short paragraph, provide an example in real life, and then solve 4 quadratics, only one of which can be with a formula, at least 2 of which have to be by factoring. To make it all quite simple in one place, here's the rubric. If you follow this rubric, you should know exactly what your score is going to be. You can see that it's on a scale from 1 point to 4 points. Technically, you could get a 0 if you don't even meet the 1 point criteria. But there are 5 rows, which means technically it's out of 20 points, which I'll adjust accordingly. 4 points is the highest you get in each category for the write-up. The solving with the quadratic formula, have to do 1 of that. Have to do at least 2 factoring, and then factoring or other method, and then how much effort and format you put into it, whether it looks professional, that is the 5th column. All right, so if I'm trying to create some equations because I'm doing this project, let's just say I know I'm trying to solve an equation, and let's say I make up my equation, x squared minus 3x minus 4. Notice again, I'm always solving for a quadratic, a power of 2. I'm always making sure it's set equal to 0. And let's say I wanted to use the quadratic formula here. Well, I could say my a value is 1, my b value is -3, and my c value is -4. Where did I get that information from? Well, that's a good question. Here it is. C is my last number, b is my middle number, and a is my first number. It's as easy as A, B, C if you set it up in descending order from highest power on down to regular number. All right, quadratic formula. Now, so I'm going about solving this. X equals -b plus or minus the square root of b squared minus 4 times a times c, all of which is over 2 times a. So now since I have my quadratic formula set up, I have my a, my b, and my c shown up right there. I can replace all these extra variables to solve for x. Remember, we're looking to solve for x, so it's already isolated. When we're solving for an equation, it's efficient to only have one variable. So if I use substitution and replace everywhere that I have a b, what I know b is, and that's -3, it makes it able to be solved with PEMDAS, order of ops. Well, look at, I have an a right here and there. I'm going to replace those values with what I know a is as well, which is 1. And last but not least, you might be guessing that c is -4. So we'll drop that -4 in the place for c. Awesome. Keep in mind that since you're going to be watching this, you can always pause this and go back and rewatch my work. So now I work it through. I'm going to just work the square root first, not changing anything else yet. Here's how I'm going to do it. Ready? PEMDAS inside the square root. So inside the square root, I have an exponent, subtraction, multiplication, and multiplication. Exponent always comes first in PEMDAS. So -3 squared is -3 times -3, or 9. Next up is going to come multiplication, so I leave my subtraction sign there. 4 times 1 is 4. And then now 4 times -4 is -16. Now I can do my slash and dash, do my subtraction of a -9 plus 16 is 25. So now what I've done is I have simplified down my square root. What I'll do is one last step. The square root of 25 is 5. Cool. Process becoming much quicker and much simpler, rather, not necessarily quicker. Awesome. So now I have a fraction, and I can start working down other things. A negative is really like saying -1 times something, or negative always makes it positive. So -3 is +3. 2 times 1 is just 2. Sweet. So now I have two equations in the form of one fraction. Those two equations are based off the plus and the minus. So my two equations are the following. X equals 3 plus 5 over 2, or x equals 3 minus 5. Notice the plus creates its own addition equation, the subtraction makes its own, or the minus makes its own subtraction equation. So 3 minus 5, that's where I got it from, over 2. Now we solve. 3 plus 5 is 8. 8 divided by 2 is 4. One solution. Or 3 minus 5 is -2. -2 over 2 is -1. Second solution, verified that I have two solutions because an exponent of 2 means we should have two answers potentially. That is the fundamental theorem of algebra. Boom. So that's how you can solve an equation. Remember, I made this up by using the quadratic formula. Now, what I would recommend doing for your factoring equations is come up with your solutions first. Say, all right, here are my solutions. I want x to equal 5, and I want x to equal -1. Okay, just made this up off the top of my head. Now, the reason I could do this is because if x is equal to 5, then kind of in reverse process, working backwards, so to speak, those are two simple equations that give me a solution of +5 and -1. Plug 5 in here, it makes the left side equal 0. Plug -1 in for x, it makes the left side equal 0. Now, the reason I bring this up is because I'm just working backwards with the zero product property. Okay, and this is what we usually got to with factoring. We usually got to this point here by breaking things down, factoring them, and setting them equal to 0, a la lessons 14, 15, and 17. But what I'm now going to do is I'm going to take these two equations, these two binomials, the things circled in green and red, and I'm going to stack them next to each other. Say, all right, x minus 5 times x plus 1. So what I'm doing is I'm working backwards, y'all, to get two factors, green and red, and then realize that I'm just working backwards in the zero product property. Now all I got to do is execute less than 5, which was foiling, aka distributive property, and get x times x, giving me x squared, x times 1 giving me 1x, or just regular x, negative 5 times x giving me a negative 5x, and last but not least, we'll go orange here, negative 5 times 1 giving me a negative 5. Boom. So I got my solutions, created 2 simple equations that worked, combine those 2 things to create factors, working backwards with the zero product property. Then I FOILed, because now I can combine my like terms to get my final quadratic equation. So for my second, third, and potentially fourth questions here, I would start with my solutions first and then work my way back to the equation. That way you guarantee that this is factorable, because not everything is in quadratics. So you got to be able to make up your own equation, factor them down, and basically do the reverse process to get your actual solutions, what I'm looking for. And that's basically the gist of the project. If you have any other questions, feel free to reach out. Do your best. Give it full effort, y'all, because this is how you're going to raise your grade. It has to be a good score and help you out. All right, y'all. Thank you for your time. Hopefully this helps.